So this will be a slightly briefer video than previous, and we will be discussing rate and how to calculate rate on an ECG. Firstly, just a quick refresher on what we talked through last time. So these are the standard limb leads of the hexagonal system. The arrows show the direction in which each lead reads on that two-dimensional plane. And this diagram represents the directionality in which each of the chest leads reads from a computer-generated internal central terminal. Here I've brought all together the standard limb leads, 6 leads on the left hand side of the ECG paper or screen, and the 6 chest leads. And hopefully now you're starting to reach an understanding that an ECG is a visual representation of the voltage of the heart, seen as a function of time and seen at various locations across the chest wall. So we're just going across the chest, taking snapshots of the heart's activity from different locations to build up a complete picture of what's going on. As an ECG is effectively a graph of voltage against time, we now need to discuss how we measure time on that ECG and therefore how we measure rate. An ECG prints on specialised graph paper. On this graph paper, the smallest boxes you will see are 1mm across. These 1mm boxes equate to 40 milliseconds in time. You will see that these small boxes are grouped together into larger boxes that are 5mm, or that's 5 small boxes across. And therefore, these larger boxes equate to 200 milliseconds in time. We can therefore reason that 5 big boxes lined up together will make 1000 milliseconds, or in other words, 1 second in time. Each lead on the ECG usually records for 2.5 seconds. So if you look at each individual lead, that box will be 2.5 seconds long. This image sets out how a standard ECG will look or print. So you will see your 12 leads printed across, each of these reading for 2.5 seconds. Then along the bottom of the ECG you have a rhythm strip. This is often reading lead 2. This rhythm strip reads across the whole 10 seconds of the ECG. Looked at in another way, as the width of a standard ECG is 4 leads wide, and each one of these leads reads for 2.5 seconds, we therefore have 4 lots of the 2.5 seconds, and the whole ECG is 10 seconds long. When thinking about rate, however, we tend to look at the rhythm strip rather than individual leads added together. As each ECG records for 10 seconds, If we recorded 6 ECGs continually, this would add up to 60 seconds or 1 minute. When we're talking about rate, we're looking for a value in beats per minute. 1 minute equates to 60 seconds and therefore to 60,000 milliseconds. If we take our 60,000 milliseconds, that's the length of time of 6 ECGs in total. And then we divide this by 200 milliseconds. 200 milliseconds being the length of time of one big box, we get a figure of 300. We can therefore conclude that in 1 minute there are 300 big boxes. Why does this matter? It matters because it gives us the 300 rule, which is a really easy way to very simply calculate rate in a ECG that has a regular rhythm. The 300 rule means that you take 300 and you divide by the number of big boxes between QRS complexes, and this gives you a rate. So in this example, there are 4 big boxes between the QRS complexes. Therefore, we take 300, divide by 4, and we therefore get 75 beats per minute. A few more examples. Here, there is only one big box between R waves, and therefore the rate is a very fast 300 beats per minute. With 2 big boxes between R waves, we have a rate of 150 beats per minute. With 3 big boxes, a rate of 100. And with 4 big boxes, a rate of 75 beats per minute. You get the picture. It's just important to remember that this 300 rule can only be used with a regular rhythm. So now let's think about what we'd do with an irregular rhythm when it came to calculating a rate. We'll start by reminding ourselves that each ECG reads for 10 seconds. As each ECG itself is 10 seconds long, if we recorded 6 ECGs continually, we'd have 60 seconds and therefore 1 minute. Therefore, with an ECG with an irregular rhythm, if you count across your rhythm strip the number of complexes, so that's the number of complexes in 10 seconds, you can then simply multiply this by 6 to give you the number of beats per minute. You could absolutely calculate the rate of an ECG with a regular rhythm by counting the number of complexes in 10 seconds or in the rhythm strip and multiplying by 6. But people tend to use the 300 rule for a regular rhythm simply because it's quicker. So to summarise, for a regular rhythm, take 300 and divide by the number of big boxes between your R waves. For an irregular rhythm, count the number of complexes in 10 seconds, so across the entire rhythm strip of your ECG, and then multiply by 6 to get your rate in beats per minute. So that's it for being able to calculate the rate on an ECG. It's really quite easy when you understand how. The reality is that most ECG machines are really quite reliable in calculating a rate. So in the clinical context, usually you'll get your rate from reading at the top of the ECG. It's not something that it often gets that wrong. However, there are situations where it's really useful to be able to check the rate on an ECG. Occasionally you may have a strip or an ECG without the rate written at the top, and obviously for exam purposes it's the sort of thing that you might be asked to calculate. And as I say, it's very easy once you have understood why and just learnt those two quick rules. So that's it for rate on ECGs, and next time we'll start talking about the access on an ECG.